Hey, hi everyone. Sorry, there was like an internet issue. Is everybody here? Okay, then let's get started. If we want to turn on our cameras, if you're here. Okay. Hi. We'll be doing some not numbers related questions today. So we're similar to the questions we did last time at the end of the class. Let's just get started with these questions. Does anybody want to read the question? Okay, so I'll read the story and then I will explain through how you do it. And if you know how to do it, you can just put the answers in the group chat, or you can follow me along while I'm explaining how to do it. So smoke signals were used by different groups of ancient peoples to send messages. A very simple code using small and large smoke clouds is given below. Messages are read from top to bottom, and the following message contains an error. Either one small cloud should be a large cloud, or one large cloud should be a small cloud. So right here in this section, we know that it's either north, east, south, or west, and there is only one cloud that has an error. So we can just maybe go through each choice and see if they match each other. So for north, you can see one matches because they're both small, like this is small. And then the second one is large. And then the third one doesn't match because this one is a small one and this one is the big one, the third one, right? And then for the fourth one, it's large and this one's also large. And then the last one, it's small and this one's small. So it seems like north is actually just the correct answer because there's only one that is incorrect and only one cloud needs to be switched, right? So down here, when we choose the answer, what is the correct message? Do we now know which one is the correct message, or do we want to try some different ones and see why they're not correct? Okay, so we now know that north is just the one that this person wants to say, but then he made an error in this third cloud. So if we switch the third to a small cloud, we know that the message is just north. So the answer here is just A. Does everybody understand? Okay. Let's move on to the next question. Does anyone want to read this question? It's very short. Okay, so beavers use coins with the following values: 16, 8, 4, 2, and 1. So let's just say these are all money. The first one represents $16, second is $8, $4, $2, and $1. So which of the following total values can be made using exactly 3 coins? Basically what this means is that the person wants to use exactly 3 coins to pay a certain amount of money, and out of A, B, C, and D, we want to see which one can be paid with exactly 3 coins. And it'll be hard if we focus on 4 numbers because like that would be a lot of work to do. And we can start by eliminating some of the choices. Like we see that B is $2, but if we are going to use 3 coins, like using the 3 least amounts, 1, 2, and 4, that actually just already adds up to $7. So we know that 2 is definitely incorrect. So we can cross this one out. And then maybe let's go on to the $23 and see what pairs we can use. We can try by using maybe the $16 coin plus let's just first use this $8 coin. 16 plus 8 will already get 24, so that wouldn't work. So let's cross out 8. And then if we use $16 with $4, that's $20. And there's no $3 coin here, so it seems like 23 does not work. But we can also try the other choices. Let's try using 8, 4, and 2. 8 plus 4 is 12, plus $2 is 14. Oh, so that doesn't work either. So let's just cross out 23 for now and look at 38. 38 is like a big number, so we should probably use like the bigger choices here, like 16, 8, and 4. 16 plus 8 is 24, and then plus the $4 is 28. So if we use all of the largest coins, we only get $28. So he actually doesn't pay $38. Then we can cross this one out, right? And that leads us to only have $13. And let's see which 3 coins we can use for paying $13. Well, obviously we can't use the $16 because that's already like larger than the 13. So we can cross this one out. And then say we use the $8 coin, and then let's also use the $4 coin, and that's already $12. And we're only $1 away from the $13, right? Then we can just use this $1 coin. Yeah, so the answer is D for this one, because we use the $8, $4, and $1, and that will add up to $13. Does that make sense for everyone? Okay. Then let's move on to the next question. Okay, does anyone read this? Or okay, I'll read it. In the parking lot shown, each car is either parked in a parking space or in front of 2 parking spaces. So we can see here like N, O are like blocking 2 cars, while like A, B, C, D, they're all like a stall. Cars that are parked in front of 2 parking spaces may be moved forward or backward in order to allow blocked cars to exit. So like N, O, P, and Q, they can move either this way or this way so that other cars can get past. And for example, car A is not blocked and can exit without any cars moving. However, car L, right here, is blocked by car Q, and if car Q moves, then car L can leave. Does that make sense to everyone? The question? Okay, so the question is asking which car cannot exit its parking space unless 2 different cars move. So let's just go from maybe left to right and just eliminate every single option. We know that car A can just leave without any car moving, so that's not the correct one. Car B is blocked by car N, but then if N moves this way, the car B can leave. So we know that like only one car needs to move for B to come out. So B is not the correct choice. And then for car C, it's the same idea. N can move either left or right for car C to come out. So only one car needs to move, and that's not the correct choice. And then let's cross this one out. Car D and car E, none of them are blocked by any cars, so no one needs to move. Then we can cross them out too. Car F, okay, it's getting a little bit complicated. Car F is blocked by car O, but car O can move backwards for F to leave. So that's still not the right choice because only one car needs to move. It's same with G, like O just needs to move back and G can't come out. So we can cross out G. Okay, H is blocked by car P. It seems like P has like limited space in front of it, but then if it just moves one stall to the right, H can actually come out. So H is still not the correct choice because only car P needs to move for H to come out. So let's cross this one out. And then now we get to car I. We see that car P is blocked in front of it and it can't move backwards because car O is blocking it. So the only option for it is to move to front, right? But then it can only move one stall to the front. And moves one stall is still blocking car I. So this means that car Q actually needs to move first before car P can clear the way and let car I leave. So this is the correct option where car I needs two cars to move in order for it to leave. Does that make sense for everyone? So what answer to this question? What's the answer to this question? You want to type in the chat if you don't want to speak. Yeah, so it's C. It's just car I. Does everybody agree? Do we have any questions? Okay. Yeah, the correct answer is C. Then let's move on to the next question. Box of balls. Does anyone want to read the story? Okay, I'll read it. A beaver has a box with an opening on the right-hand side. So right here.
How did I say it?
Sorry?
Can I say it?
Wait, what did you say? I think the internet was...
Can I say it?
Yeah, you can read it.
A beaver has a box with an opening on the right-hand side. At any time, the beaver can take out rightmost balls from the box, or put in a new ball from the right. For example, if the beaver wants triangle in between heart and circle and needs to take out circle, put it in triangle and then put in circle. Now suppose the beaver has 5 balls and the box has as shown, and 2 balls, triangle, and a square out of the box. The beaver wants the ball and the box to be in the order.
Okay, yeah, thank you, Lydia. That was great. So basically, this question is saying that the balls can only enter from this side, right? And then we want the balls in this order, but right now it's in this order. So he wants to add a green triangle and a blue square. He wants to add add a triangle and a blue square. And let's just see where he wants it. So let's say for the first ball, it's a heart in the box, and he wants the heart to be first, so that's correct. The second ball is an orange circle. That's also correct. The third ball is a yellow star. Okay, that matches. Okay, the fourth one. So it seems like he wants the triangle right here. And then let's cross that one out. The next one is the blue trapezoid. Okay, that matches. And then, okay, so the blue square, he wants it right here. So in order to put in the green triangle and the blue square, like we need to remove this shape, right? Like we know that the purple pentagon needs to be removed in order for the blue square to be in the right place. But the thing is, he wants this green square to be in first. So that means that both the purple pentagon and the blue trapezoid, so these two shapes, needs to be taken out. And then, okay, this is a little messy. Let me clear this page. So both of these needs to be taken out, and then the triangle can be put in. Then other shapes can go in, right? So let's figure out the order where this thing can happen so we can answer the question. The first step is take out the polygon, which is for all of the answers. And then the second one, we want to remove the blue trapezoid. So we can cross out C because it says to put in the green triangle, which is not correct. The third choice, the third step would be to put in green triangle because the green triangle goes after the yellow star. And then let's see. Choice D says to put in the purple pentagon, which is not correct. And we can cross that one out too. And then the next step would be to put in the blue trapezoid, which, okay. So now we know the answer is just B because A says that we need to, like, he wants to put in the blue square first, which is not correct because he wants this shape to be in between the triangle and the blue square. So does that make sense to everyone? Like, if you know the answer, you can type it in the group chat. Yeah. So the answer is B for this question. Do we all understand? Any questions? Okay. Yeah, everybody got the correct answer. Let's move on to the next question. Does anyone want to read the question, the story?
Me?
Okay, you can read.
Coco has 6 animals and needs to place other one in its own pen. 2 animals cannot be placed in touching pens. If one animal will eat the other in the diagram shown, arrows point from an animal to all the other animals that it will eat. For example, the wolf will eat the chicken, but the wolf will not eat the worm.
Okay, great job. So just to clarify, one pen is just one box. So
wait,
basically,
Kelly, what does a worm eat? What does a worm eat?
Yeah, so in this question, a worm actually doesn't eat anything, and I will go through what each animal
Then how
eats.
does it live? Like, how does it live?
It eats dirt.
Oh.
Yeah. So we're just focusing on this question. So we all know what a pen is, right? So one pen is just one box, and it's basically saying that if one animal would eat another, they can't be like in boxes that are nearby because the animal will get eaten. So let's just go over what each animal eats. For I think this is a sheep. It only gets eaten by this wolf right here, and it doesn't eat any animal. And then for the wolf, it eats this sheep and this chicken maybe. Okay, and then for this one is maybe like a fox. I'm not sure, but this fox will eat only the chicken, and it doesn't get eaten by anyone else. For the chicken, it gets eaten by the wolf, but it can also eat the worm. So is that clear with everyone?
Yes.
Okay, and then the worm is kind of sad. It gets eaten by like chicken and the gecko, but it doesn't eat anyone. So it's just like a sad little one. And for this gecko, maybe it eats the worm. So for everyone, now we know what each one eats and get eaten by. Okay, so let's move on to the question. The question is asking which of the following choices is not a good placement? Okay, is not a good placement. So let's just see, let's just go through them one by one. Let's make this a little bit bigger. So in the first box, there's a chicken. A chicken gets eaten by a wolf and fox, and none of them are nearby. And chicken also eats a worm, and none of them are nearby. So that's good. And then for the sheep doesn't eat anyone, and it seems like the wolf is not next to it, so it's not. So this one is safe, the sheep is safe. And then look at the gecko. The gecko only eats the worm, and the worm is not nearby. The worm is like right here. So the gecko is safe. And then the wolf eats the sheep and the chicken, and none of them are close to it. So the wolf is safe. And then the fox will eat the chicken, but chicken is like far away right here. So the fox is safe, and the worm is not close to the gecko and the chicken. So worm is also safe. So it's not A because all of them are safe. Okay, I see that some people are saying option D. Okay, so let's see what D is about. D has the chicken on the first box. Chicken gets eaten by wolf and the fox, and none of them are nearby. The chicken eats the worm, and the worm is not nearby, so the chicken is safe. Now let's look at the sheep. The sheep gets eaten by the wolf, but the wolf is not nearby, and then the sheep doesn't eat anyone, so the sheep is safe. And let's look at the gecko. Gecko eats the worm, and the worm is actually right next to it, so the worm is not safe. So yeah, so what everybody answered is correct. D is the option that is not a good placement because the worm will get eaten by the gecko. So does that make sense to everyone? Why D is the correct answer? Any questions? Okay. Let's move on. Special towers. Anyone want to read this question?
Me.
Okay, you can read.
Consider the tower shown. Consider? Yeah, consider.
Yeah, consider.
A tower
How
is
about
special if all towers to the left of it are shorter and all towers to the right of it are, I can't see this word, are taller.
Okay. Great job, Andrew. So do we all answer the question? So find how many special towers there are. And a special tower is when the left of it are all shorter and the right of it are all taller. So we can just go through this question by process of elimination right here. We already know that for the first tower, first tower, everything to the right of it needs to be taller than the first tower in order for it to work. So we can see that the green tower next to it is actually shorter than the tower, so it's probably not the correct choice because not all of the towers are to the right of it are taller. And then let's look at the green one. The green one, the black tower left of it is taller, so it's not a special one because it doesn't follow this restriction. And then the third one, pink tower, the two towers left of it are both shorter, so that's good. And then let's look at every tower right of it. Okay, so we see that everything right of it are all taller, so we can count this as one. The pink one counts. And then the fourth one, everything left of it are shorter. And then, or is everything right of it taller? No, the right next to it is shorter than the fourth one, so this one doesn't count. And looking at the fifth one, this dark blue, the tower left of it is taller, so that doesn't work, and so this one doesn't count. And looking at this red one, which is the sixth tower, all the towers left of it are shorter, but if we look to the right of it, the gray, is this gray? Yeah, this grayish tower is shorter than it, so it's not special. So far we only have the pink one that's special. Then let's look at the next one, which is the seventh, this grayish tower. The red tower left of it is taller than this tower, so it's not special. So we need to cross this one out. And then the purple tower looks like everything left of it is shorter, and all three towers right of it are taller. So this one actually is another one that is special. So now we have two that are special. And then the next one is this dark blue tower. Everything left of it, okay, is also short, and then everything right of it is tall. This is another one that's special. So far we have three special towers. And then the second last tower, which is this like reddish brown tower, everything left of it is shorter, but the gray tower right of it is not taller, so this one doesn't count. And then for the last tower, not all of the towers left of it are shorter, so we know that the answer is just C, because only the pink one, the purple and the blue are special towers. So the answer is just C. Does that make sense for everyone? I can't see anybody's face.
Yes.
So
Yes.
okay. So we all understand? If anybody doesn't understand, can you just call out, because I cannot see. Okay, seems like there are no questions. So let's move on to the next one. Oh, does anyone want to read the story?
Me.
Okay, you can read the story.
Beaver Cleveria discovered a table of symbol carved in wood. After studying the table, Cleveria figured out the agent called the symbol assigned into a world. The symbol assigned the clone or two from a single. This image is the code for the letter row meet. For example, the letter H is in code as shown. This is really hard. I don't know.
Okay, good job. So this may seem very complicated, but it's actually very simple once I explain it. But let me first change this to a separate app so that I can write on it. Okay. We're right here. So this is just a chart that corresponds to each letter. We need to use figures from the left and figures from the top to find the corresponding letters. So let's just name these little shapes. Let's say this one is round. This one is maybe like pointy.
No, this one, the last one, maybe it looks like a rose.
Yeah, it can look like anything. I'm just trying to name it so that I don't know, this one maybe like spiky. Okay. And then these ones at the top, they just have like lines and like circles. I'm not gonna name every single one of them, but you know that they're all different. So now we have this code message right here on a tree. Basically, we need to like figure out the shape on the outside and the shape on the inside and find the corresponding letter according to each image. And the question is asking what
L.
is
The
the
first one is
message.
L.
Yeah, so if you know the answer, you can type in the chat. I will just explain to everybody. The first one, the outside is the pointy shape, which is this one. And then the inside has 3 lines. So if we point it here, it's L. So you look horizontally for these shapes and vertically for the shapes inside. Does that make sense to everyone? So the first letter is L. Are there any questions? Because I can't see anyone, so. Okay, then I'll move on to the second image. The second image also has a pointy outside, and the inside is this circle with 1 stripe in it. So it's right here. Then we can cross. So maybe I'll do it this way. So for the pointy one, we look horizontally, and for the circle with a stripe in it, we look vertically, and that leads us to O. So if we look at our answers, we can already cross out B and D because they don't start with O. And looking at A and C, the first 4 letters are all the same. So we know that this is V and E, and we can just skip to the 5th one just to save time. The 5th one has a round outside, and the inside is a circle. So if we match it on this chart, looking this horizontally and this vertically.
Did you go down to let me see the letters in front?
Yeah.
Okay, thank you. I know what.
So this is W. At this point, I think we already know the answer because the 5th letter of C is M and the 5th letter of A is W. And we already know from breaking this code that the 5th letter is W. So the answer will be Bluff Water, which is A. Does everybody agree? Any questions? Any questions with you guys?
No.
Okay, so let's do one more question. Does anyone want to read the story?
Me.
Okay, you can read.
There are 5 positions in the Beaverumba dance. Each position after the first involves moving either exactly 1 arm or exactly 1 leg from the position before it. Robert remembers the first position of the dance but forgot the correct order of the 4 positions.
Okay, good job. So Robert is trying to dance, but he doesn't know which move he needs to dance with. So we know that the first position is with his both arms down and both legs down. And then also a very important information from this story is that he can only move one arm or one leg at a time. So he can't just like raise his arms and legs all at the same time. He needs to move one at a time. So the question is asking, what is the third position of the dance? Then we can figure out one by one. Like we know that the first position is both arms and both legs down. And
it is A.
Okay, you can keep this to the end. So for these other four positions, let's figure out what the second position is. The second position should only have one arm or leg that's different from the first position. So let's look. For this one, okay, both arms are up, so that's definitely not correct because he can't move two arms at the same time. The second one, this arm is up and this leg is up, so that's also not correct because he can only move one. And then this one, okay, both his arms and his leg is up, so that's not correct. So we know that this one is the second one because only one arm raised. And then now let's look at the third position, which is the one we want to find. The third position should only have one arm or leg that's different from the second position. Let's look maybe at this one. This arm is correct, but it has like one arm and one leg that are different, so that's not correct because two limbs moved. And then let's look at here. Seems like this arm is right, and then only one leg moved other than the arm that's raised.
Teacher,
Yes?
may I go to the bathroom?
Yeah. Okay, so we know that this is the third position because it's only one arm or leg different from the second position. So what is the answer to the question? You guys can call out.
C.
C? Does everyone agree with C? Any questions? Okay, I'm assuming there's no questions because I cannot see you guys. Okay, let's move on. Anyone want to read this?
Can I do it again?
Sure, yeah.
An astronaut map is shown. It shows all of the possible travel routes between planets. For each route, it shows whether it can be traveled by rocket or by spaceship or by both rocket and spaceship. For example, rocket, spaceship is a list of space vehicles that will take the astronaut from a planet to that other planet. Suppose the astronaut wants to travel from that planet to Earth.
Okay, good job. So we are moving from this dark blue planet to Earth. And the question is asking, which of the following is not a list of space vehicles that the astronaut could take? Then let's start from this dark blue planet. We see that it can either go this way or this way. Then we can maybe just start with one way and just start with the spaceship. If it takes a spaceship and goes to this orange planet right here, the next way it can take is either this way or this way. So either a spaceship or a rocket. Then let's just take the one to the left of it first. Let's mark down. The first route, we already took the spaceship, and then the second, we also took the spaceship, and then now we're here. You can either take the rocket or the spaceship, then let's just take the spaceship first. I mean, take the rocket first, and then we get to Earth. So that's one option. And if we want to match it with the results, option C is, option A is spaceship, and the rocket. So that one is an option. So we can cross that one out because we're trying to find the one that's not an option. Okay, so let's erase everything and then still start here, and then we still take the left side route, and then but this time we'll go to this planet by rocket. So the first thing we took was the spaceship, and then it was the rocket, and then the next route to take is this way to Earth, which is the spaceship. And let's look here. Rocket, spaceship, rocket, and spaceship. Oh, that's not even an option, so and let's just erase everything and then start from the right side, which is this way. Wait, actually, we missed one route from Earth to the orange planet, and then from the orange planet to here. And then we took the rocket last time, so this time we'll take the spaceship. So in that order, we took the spaceship. We took spaceship for all of it, but that's still not an option, but we want to keep everything tracked. And then now we can go to the right side with the rocket. So let's start with the rocket, and then we reach this planet. Seems like there is only one option.
I am big.
So it's the rocket, and then now we're here, and then spaceship. And we can cross out another one, which is option C, matches what we just did. It was the rocket, and spaceship. So let's cross this one out. Okay, it seems like we've been taking like the simplest routes, and there are still two more options that we didn't cross out. So let's try seeing which route this one took. So it started with a rocket. So rocket, it goes here to this orange planet, and then it went on to a spaceship. So it went back to Earth. Okay, that also works. And then the third route was a spaceship, so it probably took this way and went here. And then he went again on the spaceship, which is over here to this blue planet.
I know the thing already.
Yeah, and then he took the rocket to the Earth. So option B actually works. So that leads us to option D to the correct answer, which is the only one that does not lead the astronaut to the Earth. Does everybody know? Does everybody understand, or should I walk through why this one is not correct? So what is the answer for this question?
D.
Okay, so do we have any questions to this problem? Okay, let's do maybe one last question. Does anybody want to read?
Me.
Okay, is anybody other than him who wants to read, or? Okay, then you can read.
A beaver believes plates are only arranged properly if all the large plates are on the left followed by all the medium plates, followed by all the small plates. For example, a beaver believes the three large plates, the three medium plates, and two small plates shown are arranged properly. The beaver would like to add a large plate and arrange them properly.
Okay, great job. So the beaver wants to add a large plate, which is one of these, to this rack. So it needs to be ordered from large to small. So the large plate can either go in this gap, this gap, this gap, or this gap. So the question is asking, of the 8 original plates, what is the fewest number of plates that must be removed? So basically all 4 of these gaps can work if you remove a certain amount of plates, but we're trying to find what is the fewest number of tries we can take out to fit everything in. So that probably means that this option will win, because for all of the other 3 options, you need to remove some extra large plates, which are not necessary in this case. So in this case, we want to put the large plate in this gap. And there are many ways you can take out plates, right? You can either just remove all 5 of these plates and then place the white plate, the big plate in, and then place them all back. But that's not the fewest number of plates you can do. So another option is, if you keep this green plate where it is and move this plate over here. So now this gap is empty, and then we can keep these 2 yellow plates where it is, and then move the last one over to the empty space we just cleared. So now after we moved 2 times, this space right here, let me clear this. This space right here is now clear. And then we can put the white plate in. So how many tries did I take to, how many plates did I take out to put this large plate in? Okay, let me maybe explain one more time.
The answer
So, sorry?
is the answer B.
B. So it's asking what is the number of plates must be moved. So if you followed what I just did, I didn't move this plate. I only moved this one over here. And then I also didn't move these 2 plates. I moved the yellow one over here. So how many plates did I move?
2.
Yeah. So what is the answer to this question?
A.
Good job. Does everybody understand? Does anyone have any other ways to do this question, or any questions? Okay, I guess there are no questions, and this actually leads to the end of our class today, because yeah, class. So we'll just end on this question right here, and then does anyone have any general questions?
Why the end of the class? Like seriously.
Yeah, because class ends at 8:30 and it's already 8:30, right?
Oh.
Yeah. So
I thought my mom said she thinks it ends at 8.
ends at 8. No, it actually ends at 8:30. So I hope you guys learned something and had some fun, maybe. Next week, we actually won't be having this math class anymore. So we'll be having a Minecraft playing game. And more information of this will come out.
Minecraft?
I hope.
Do we play Minecraft?
Yeah, so I won't be teaching this class, but I think Michael will be, but where they will be playing on a Minecraft server, and anyone with the Minecraft app can also join. So that's it to today's class.
Wait, are you playing
If
Minecraft?
you guys,
Minecraft costs money.
yeah, so if you have the app, you can join to play, but if you don't, you can just watch them play, and maybe they'll teach you some tricks, I guess. I'm not sure what's gonna happen.
Won't even come. I mean,
mean,
what's
it's
the point?
I'm just
the app.
a beginner, and I just created some walls.
Like, are you gonna
Maybe
buy
they'll
in
be
the
just
future? Like,
playing
what's the
some
point of
games.
even coming then?
Yeah, more information will come out later this week. I'm not too sure what's going to happen for the class. So yeah, so for the math
I know
class,
why is this the last class, because it's almost Christmas. 6 more
Yeah.
days until Christmas.
Mm-hmm.
So that's why they're ending this. But Michael's not.
Well, I hope you guys all have a very
Does
happy
anybody
and
know?
safe holiday. Sorry?
Why do you say holidays instead of Merry Christmas?
Because some people may not worship Christianity,
I
so
know.
we just say happy holidays, right? So that is it to today's class. I hope everybody had some fun and learned something, and stay safe over the break, and see you guys maybe later next week. Yeah.